Good morning. Thanks to the organizing committee for inviting us to share with you some of the experiences of La Rosa Sofruco, specifically in European plums and other fruit trees. Our company has 1,300 workers, 2,200 hectares planted with evergreen leaves fruits, vineyards. All what we produce is processed by ourselves and we also export this. Therefore, we are a vertically integrated company. Today, the challenges for agriculture are very heavy because of the decrease of the rural population, water scarcity, and extreme temperatures as well. Obviously, the production has to be sustainable and the markets are always more demanding. In order to meet with these challenges, we have included several technologies in this case. And as you can see here, since the invention of the wheel, human being has always been looking for new technologies. Here we can see a man ply with an oxen. In ancient times, we used carts until today with the use of satellites. So we have defined a technology that is a group of resources and methods that, if we apply them in certain fields, may produce goods and services required by human beings. What do we do as La Rosa Sofruco? We have three main pillars, for instance, construction of crop handling in order to improve performance of pears, vineyards, etc. Inclusion of new machinery for optimizing works, personal or group harvesting platforms, lateral pruning, vineyards clearing, pre-trimmers, overhead pruning, electric pruning, planting machine for vineyards, spraying equipment for accurate applications, design and construction of new machinery for applying sanitary products, and finally, site-specific handling for irrigation design, fruit trees nutrition, plagues monitoring, measured soil compaction, frost handling, monitoring and effectiveness of bees flying, irrigation control, and microbiology soil improvement. And today we have included a national enemy control lab. So as you can see here, we have the handling programs per species. This means all the years we meet in order to check our safety program for each crops, and we check what happened last season, what's good and what's bad. We correct all the failures and then we keep the good things. Then we have included new machinery to optimize our work. And here you can see for the soil preparation, we have used a new equipment that is used for the new furrows with a good cleaning or use on a bulldozer. Then we use a rotary trailer, and finally we use this and we make the windrows, because for our features it is necessary to use these windrows. We have also included this machine for planting fruit trees. This is a machine that works as similar to the machine of corn, but it has a GPS, so it leaves the plants at the right place where we want. So we can use also for cut plants and for plants in bags. The lateral pruning I use in this company for longer than 20 years. So as you can see here, where we can have the right angle that we need for the fruit trees. For instance, in the picture to the left, you can see that the angle of the saw is cutting close to the axis. And the machine to the right, you can see that it's using both sides. This is in the spring. This is for thinning the flowers, in this case pears, if you can see here. In both crops, whether we have pears or plum trees, these have some vegetation, and on the right is it's a little bit with some weeds, but all the work is done by us. Electric pruning, we have included this in time, and this has allowed us two things. to include workers who are very good for pruning because they're very experienced, but they are old and their hands are not enough to use the normal pruning cutting machines. So we also have women because the technology is easy to use and the physical effort is very low, so the performance is much better. And then if we use the platform, it's much easier because people don't have to work, and this platform is used at a speed of 0.3 kilometers per hour or less, and this allows to have accurate pruning, and the person may move on the platform. We also have some other piece of equipment that is modern. Here we can see this machine for 4,000 liters with 5 ventilators on every side. We use all the nozzles where we can use nearly 100 or 200 liters up to 2,000 liters per hectare in case we really need that. This allows us to have an excellent coverage with the proper humidity that we have defined according to the initial setting. This changes according to the phenologic status of the crop. Today, in order to comply with our premises and our policies as a company, we do not burn the remains of the crop. And here we remove nearly 100 hectares per year, and we plant them the next year. Therefore, we have a big amount of biomass. As it is not burned, we have to find a solution in order to include this capture of carbon that we had done for many years. And we found this piece of equipment where we can put all the trunks with roots and everything, and we start making chips. Then, as this is done in winter, this is get moisture, and we start with compost for about 2 months, and then we spread all this on the ground and we use it ideally in the areas with more stones. When we include this organic matter, which is very unstable, this allows us to improve physical conditions of the ground, especially in those areas with more stones. This is a piece of equipment that is hard to find it, but it's very, very good for our purposes. Now, talking about the site-specific handling, we can differentiate 2 types of handling: the systematic sampling and proximity sensors. For the systematic sampling, it is to create a grid, all the dots that you can see here, in order to do the measurements in all of these plots. In order to do this, we use this formula. It's a statistical formula where we can adjust the degree of accuracy in the sampling. So each of the crops, or each group of crops, has its own personal or dedicated grid. And here we can do all the measurements that we need to do. The whole plot, the 2,000 hectares, are under this grid. So what do we do with this grid? For instance, here we can design the irrigation, this system. In this orchard of 17 hectares or 15 hectares, we take about 20 points. We measure the physical and chemical features of the ground in order to do first the chemical amendments of nutrition or fertilizers that we can do per areas, and also we measure the field capacity, the permanent wilting point, the clay content, sand content, lime content, and we weight the different variables. And then after that, we have this map with the homogeneous areas for handling. In this case, the homogeneous areas for irrigation. So this is sent to the designer, and he sends us back this irrigation plan for the 3 homogeneous handling areas. So this is very useful because there are some areas with more clay, with more sand, or more stones, or more retention of humidity. Therefore, this has to be associated to these characteristics and not to over or under irrigation, and that is when we do it physically. So when this marked and everything is homogeneous. But for this zone we have their irrigation times and frequency as well. So today it's very, very useful, and this is used for measuring compaction. The orchards have been planted many years and there is a rotation. So an orchard of 30 years old has had 30 years of machinery, people walking around, etc. So the soil has been compacted because of a man walking around, or because of the features of the ground itself. In order to solve some problems, we made this grid. This one has a lot of more dots. It's more dense than a normal grid, but we wanted to know accurately how the ground was in terms of compaction. So we measure in the windrows in between, the windrows on top, and where the tractor wheels pass on, in order to define how the compaction is in these areas. So here we can see what we have used, and these are the tools that we usually use. We use the one not the one on the top. We use the one at the bottom, and we are more modern. These use a GPS, but the one doesn't have a GPS. So these are the results, and here we can see the compaction that is on the ridge and at the center of the windrow, not between the wheels of the tractor. And here on the red area you can see the most compacted, the yellow is the intermediate, green less compacted. And as you can see here in the picture, the roots cannot penetrate the ground when we have more than megapascals or 300 pounds per square inch. And we could have some compaction problems with 1 megapascal or 125 pounds. So based on this, we know how the ground is, and we have to start with the handling. So here we have to define physical, chemical labels of both of them. In this case, we start using a new machinery with the bulldozer, and then we apply, this is for the windrow in between, and on the one above, we apply gypsum. And after 1 year, we measure how it's going. This has changed, and statistically, there are differences between the physical and chemical treatment versus the initial status of the ground. And we have a witness, let us say, to know if it was correct, and so it was. So treatment works, but we have to measure. Everything that we do, we try to measure in order to make decisions that are not at random. So what we do today is, I would say it's very interesting. We take advantage of our monitoring system, which is very professional. We have a person in charge of this with a monitoring team. So we use the grids. We measure in each of these points the presence of plagues or diseases that are typical of these crops that we can see here. In this case, we can see the population of the red spiders on the leaves, and you can see here at the edges of the crops there is a higher amount of individuals per leaf, and inside of the crop there are fewer amounts of them. In this part here there are fewer because here there is not much transit. So based on this we can apply directly to these areas. Or we can make a full spraying, but this tells us about what we have to do. I mean, before we used a spreadsheet full of numbers that nobody understood. But today, this is now a grid with the georeference, and these dots become a map that you may call them a map of colors, but it's a map where we can usually see if we have a problem, where it is located, and to take the right measure to solve this. So here we can see in another species, these are oranges, how this technology works. Here on the left, that is on red. So because it was full of black scales at the sprouts, and here there was a dot that is a little bit healthy. Then we started an application. We measured everything again, and the treatment was very good. Here you can see how it changed from red to green. And we have just a little spot on red here. So we applied once again. This is basically a mineral oil. And here you can see the final result. I mean, when we have a problem, we take actions. We check what happened with that action, and this finally means a solution. So we did right, or then we have to repeat in order to solve everything. So this is a very good tool for plant control and diseases. So this is the new piece of equipment, I would say. 1.5 years, we defined it. We wanted to start a lab for natural enemies. With much effort, Christian Sanchez, who is in charge of monitoring, he started to work on this lab, and today we have cryptobags and rhizorum for control of mealybugs and for the wide scale. Soon we will use other enemies, but this is very interesting to share because we are already creating our own enemies. So this is a very big step in terms of sustainability of the crops. It means effort, dedication, technology, but we can do it. And here we can see avocado trees. There are many, and also citrus as well. And also deciduous leaf trees whose flowers and fruits get frozen. So we have arrays of sensors all over the place. And this network is measuring every 15 minutes the temperature of the moment. And with this, we create these maps so we can know the performance and the dynamics of the low temperatures, mostly during winter. And this year, we discovered that there were two dynamics, some frost coming from the river and the other one coming from the hill. These are very different in terms of their features, and we have to solve them differently. So this is very interesting to know what's happening in the field. And let us say 20 years ago, we had a field where we have very few plums, very few, and we didn't know what happened there. So finally, with these sensors, we realized that in this is a frost area, and it may happen in spring during flowering. Therefore, what happened at that time, it was a frost that burned all the flowers, but we didn't realize until the fruit did not set. Now, let us talk a little bit about the proximity sensors on the floor. This is very new. It was tested in Chile here at La Rosa 3 years ago with some avocado trees, and it measures the gamma radiation emitted by the ground. It measures uranium, I think, thorium, potassium, and something else. And these radiations are very stable from 1 year to another. So the machine tests, measure the gamma radiations, and then take samples in certain points. And this is made with the calibration. So with this map of radiation is compared with the ground. So this is a relation between the nutritional content and physiochemical properties of the ground and the gamma radiation. This is stable and very accurate, and the results are very accurate. So what do we do with this? We can measure organic matter on the ground, we can measure phosphorus, potassium, pH. And with this, we have a very good map in order to know what the problems are, where there is a deficit or excess of components, and not to apply excessively. And here we can see, based on these properties, chemical and physical properties of the ground, we can see in an orchard that it has this awesome phosphorus. This becomes a dosage map. That is to say, in the zones where there is less phosphorus, we apply more, and when there is less, where there is more, we apply less. So we can cite specific, manage the content of phosphorus, in this case, or potassium. And with this, we can do with all the elements. In order to have a standard, what we want to use phosphorus on the ground, we can use the right doses in each of the areas of the crop. So here we also we can use for applying soil-active herbicides. You know that these need to comply with certain features of organic matter of the ground, and clay on the soil, and obviously CIC, so that it is not lower than what we need and not to damage the plants. So for a herbicide, we use more than 10 milligrams per 100 grams at the sick of the ground. In this case, we comply with this. We need to have organic matter for the ground higher than 1.5%. We comply with that. And to have clay on soil of more than 10%. In this case, we comply with this. So it is very safe to apply this type of herbicides, in this case, for this study. As we can see here, a couple of slides before, we have designed an irrigation system using this sampling or sampling with the grids. In this case, we can use the proximity sensors, that is the gamma rays sensors, to design the irrigation system. So with this sensor, we define the properties that we wanted to measure. That is the percentage of sand, lime, the percentage of clay, hydraulics. And based on this, we weigh each of these variables and we make this map of similar features of ground. And then we provide this to the designer and he gives us this map. Well, you can see this piece that is not included. It's just parts of it that is not on the slide. So here we have two areas for even irrigation. Finally, we are today using satellite NTI, and we can also use drones in order to know the behavior of the vegetation or the vigor of the plants along the growth. We don't do it in all the crops, but we can do it as we really think it's necessary. So here we can see that we started on October the 2nd, November, December, and January to March. And here you can see the evolution of the NTI. So that is the vigor of the plants. If you can see here, if it goes up and down, and then there's a problem. And then we have to find a solution. There are many supplies of this technology. So if you want to buy it, you will have to use it. Otherwise, you better don't buy it. But if you do, use it, because it's very useful. Finally, I wanted to show you this. That is an estimation of the crop of European plums. We made a grid, a sampling for this, and here you can see the developments of the grid. We have 20 and so points. In each point, we have a tree, and we measure the fruits. This was 2 weeks before the crop. The containers were weighed, and we measure, the fruits were weighed. So here we can see the yield per hectare, and the result was that we had 39,552 kilos per hectare. So the real kilos for this crop were 40,600. So we have a deviation of 1.8% less than the estimation, which it means, the tool works, and it works very well. So here we have to get another derivative. Here there are different colors, red, green, yellow, brown. Each of them means different kilos per hectare. So here we can show the weights of the fruits, where the greenest are bigger fruits, the reds are smaller fruits. And here this is the performance map. So if we look at the red zone, we have 15,000 kilos per hectare. The green zone has 52,000 kilos per hectare. So the potential of this crop is 52,000 kilos per hectare. Why 52 and not 60? Because the average between 45 and 60 could be 60. You have to just find a goal. You define that. I just put 52,000 kilos. But we got 40,000, so we have a breach of 2,000 kilos per hectare. So how can we get the potential that we need? Because we are far away. So what we did, we measure ground compaction, NTI. Here in this chart, you can see how we increased the compaction in the deepness, because we didn't prepare when we planted this orchard at 60 centimeters with 3 megapascals. So it's very strong. So there is not a direct relation between compaction and the production. So here the NTI is also very good. So this is something that we have to analyze in order to get the better potential of the crops. This technology works. We have proved that the grids allow to have a better estimation. We have proved that it allows us to know what is the potential of a crop at that time, and we can try to get closer to that potential. So here we have to ask the following question. Is it compaction? Is it irrigation? Is it nutrition? Is it pruning? Is it sanitation? So these are the variables. These are the variables that we have to consider in order to know what the limitations are, or in order to arrive at the potential. So this is called site-specific management, and it is born from the variability of the ground and how we can manage all this. So finally, these are the considerations. Agriculture, if using technology, we can use it in the production. From the beginning of agriculture, man has used technology. The use of a spade is technology. The use of a tractor is technology. The use of a drone is technology. But we have to know how to use it. If you have a spade but you don't know how to use it, it's useless. So if we have a drone and you don't know how to use it, it's useless. So we don't have to be afraid of using new technology. And when we start using new technologies, that must be a commitment to use it and not to hesitate when we have problems. The problems are human beings, the user. No, I cannot use it, I don't have time. People are not trained. I have humidity sensors, but nobody uses it. I have maps, but nobody knows how to use them. That is not useful. You have to use the maps, you have to use the sensors. I have a ground mapping for the fertilizers or for the mineral contents of the ground, but I do not do the amendments. That is not useful. You're going to have a lot of costs, and finally the money goes to waste. Before including more technology, we have to know what the goal is. That is part of what I said before. You don't have to use Just because someone else is using, I'm going to use a drone. If I need it, I will take it. Otherwise, I don't. And why I don't need it, maybe it's useful, but I don't know. I need the technology, I need the training for the workers, and this is fundamental to include that technology in the field. Every year we have training in terms of pruning. Today is online, and every time we train them again on irrigation, how to clean the piping, how to use the sensors. Otherwise, we are going to start lagging behind. So we have to update the knowledge. So this is what I wanted to comment. And well, that is it. Thank you very much.